Hello Professor and hello everyone. This is my presentation related to my research work that I have done in my master and I am doing in my PhD, which is the energy storage devices, especially supercapacitor and quantum dot LED. Sorry, I forgot to tell my name is Awais Ali and I am PhD student. So here I will start my presentation. This is the contents of my presentation. I will tell you about history of supercapacitor, some motivation for my work, and introduction, working of supercapacitor and quantum dot LEDs, their applications, and some summary. This is the history of supercapacitor. Supercapacitor is basically originated in 1957 by General Electric, and this is basically double layer capacitor. And after that, Standard Oil of Ohio company, they received the certificate to discover the commercial supercapacitor in 1966, and after that they issuing the license to NEC Japan, which is start to produce supercapacitor in 1978. This is the motivation for supercapacitor, that is the basically the power capability, have very high power capability, and supercapacitor are environmentally friendly, and they can work in very cold weather like minus 40 degrees centigrade. But there are some limitation in supercapacitor like that, and they do not have very high energy density like batteries. So what is the supercapacitor? This is the basic question. So supercapacitor is fast charge and fast discharge capability, like within seconds it can charge, and they have very high power density, but they have lower energy density as compared to batteries. Supercapacitor perform midway between conventional capacitor and electrochemical cell like batteries. Like it is in between capacitor and batteries. Like capacitor have very high power density and batteries have very high energy density. So supercapacitor is intermediate between of them, and they are highly reversible, like they have very high cycling stability, like sometimes more than 500,000 cycles, and a supercapacitor can operate up to minus 40 degrees centigrade, which is very good for supercapacitors. So this is the some basic difference between supercapacitor and batteries. Like supercapacitor can be charged very fastly as compared to batteries, and supercapacitor have high power density and high energy density. So this is the basically supercapacitor difference between supercapacitor and batteries. So this is the like chart where we can see the what is the difference between batteries and capacitor, and supercapacitor is intermediate between of them, like they have energy density and power density intermediate between between capacitor and batteries. Like here is some examples of supercapacitor. Most promising energy storage device, they have high power density than batteries, high energy density than capacitor, and very long cycle life. So this is the energy density, how we calculate energy density in supercapacitor. Basically there are two parameters that control the energy density in supercapacitor. One is the capacitance of capacitor and other one is the operating voltage. We can increase the capacitance by increasing the surface area of our material, by increasing the conductivity of material, or by decreasing the resistivity. The other option is that we can increase the potential window by using multiple redox couples, by choosing the electrolyte, or by choosing the type of device, like a symmetric device or hybrid device, something like that. So basically there are two type of supercapacitor. One is double layer capacitor and other one is pseudo capacitor. And the difference is that in pseudo capacitor we are using metal oxides or metal sulfides, and in double layer capacitor we are using activated carbon, carbon aerogel, graphene, like some carbon type materials. And in hybrid capacitor we can use both, one electrode from double layer capacitor and other one is from pseudo capacitor. So this is the energy storage mechanism. How can supercapacitor store the energy? In double layer capacitor they have high surface area, good electronic conductivity, long cycle life, high chemical earth thermal stability, high power density. But in Faraday charge transfer, like in pseudocapacitor type, they have high specific capacitance, high energy density, but low conductivity and poor cyclic life. But in hybrid device, when we choose